Okay, now we're going to look very briefly at the requirements for installing rainwater systems. So the key objectives for this part of the session, I want you to be able to describe each of the three types of underground drainage, give a basic description of what we should consider before installing a new gutter, and identify various gutter brackets and state the maximum clip distances, including the requirements for supporting unsupported fittings. So, before we install any new rainwater system, it's beneficial to know the types of underground drainage system. There's three types that we need to be aware of. One is a separate system, one is a partially separate system, and one is a combined system. And we're going to talk about what each of those mean now. Okay, combined system is the most simple. It's where you have all of your pipework, all of your drainage pipework, be it the fill water and the rainwater, all going into one pipe, one combined sewer. I'll very briefly talk about this. RWP stands for rainwater pipe, FWG is fill water gully, SVP stands for soil vent pipe, if you're interested. Okay, so all of our water, be it rainwater or fill water, all goes into one pipe, a combined pipe for a combined system. Worth noting that your rainwater pipes on a combined system must have traps on them. Traps are there to stop smells getting out, and you don't really want potentially to have a running outlet underneath a window, for example, and you've got all the smells from the sewer coming up through that running outlet. So every time you open the window, you're getting all these sewer gases blown into your house. So if you have a combined system, or for example, potentially in a partially separate system, some of those pipes will be connected into a fill water sewer as well. Any pipe that's connected into a fill water sewer, rainwater pipe, should have a trap on it to stop the smells getting back out. Okay. So a partially separate system and separate system we're going to look at together. I mean, a separate system is pretty simple, really. It's just the opposite of a combined system. Essentially, it has a completely separate sewer for rainwater, which in that rainwater would be taken away and just discharged into a water course. It might be a river or a stream, something like that. But then it doesn't need to be treated. You know, it's save a few pounds on treatment, as you're not having to treat all of the rainwater and the fill water as well. You just need to put the fill water into the treatment plant, and that's a separate system. A partially separate system might be a system in which some of the rainwater might go into the fill water, like you can see RWP rainwater pipe here. That one's going into the fill water, so that's a partially separate system because the rest of it is going into a separate surface water sewer, or it's shown on here as potentially going into, this is an alternative connection rather than having a surface water sewer. An alternative arrangement could be having a soak away. The requirement for that is essentially having a largish garden which has soil which kind of allows the water to soak away fairly easily. That wouldn't be a good idea for like clay soil or whatever, because the water would just sort of build up there and you'd end up with a bog in your garden. Okay, so when would a customer need a new gutter? That's the first question really we should be considering. Most often it's going to be if the gutters start to look old, they become damaged, or if they start to overflow. But I mean, some of those issues could be fixed with simple maintenance, and it's worth kind of letting the customer know that, be honest with them and upfront with them, and sort of let them know what issues are sort of terminal essentially, and which ones could be fixed fairly easily with a bit of TLC. So if the old gutter's overflowing, it might be to do with a blockage, for example. You can have silt and leaves building up in the gutters and downpipes over time that will need to be cleaned out from time to time, and you know safety procedures for that. Wear a face mask, wear waterproof gloves, etc. And be careful, be safe when working at height. You can actually sort of reduce this build-up by installing a leaf guard. You can see it in the picture at the top here. That sort of stops the build-up of leaves in the gutters. You can quite often fix leaks fairly easily. For example, with PVC guttering, it might just be a case of clipping the fitting back in, or sort of replacing or changing the position of the rubber, for example. If cast iron guttering is leaking, it might just be a case of the putty might have cracked, so you scrape out the old stuff, renew it, and tighten up the bolt again. Or it might not even actually be the gutter that's overflowing. Potentially, I mean, it could be an issue with the roof felt. If the roof felt, when the roof felt gets old, it can start to split. It can allow water to penetrate through it. So if you actually see water sort of dripping down the front of the fascia board, for example, there isn't actually a fascia board fit in this picture, but it could actually be a result of just old felt. You know, it's the water's penetrating through the felt. So pre-installation checks. If the customer decides they do want to renew the gutter, they don't want just some maintenance, then it's worth looking at considering what might need to be done as well as part of that job. Often sort of fascias, which is the front bit that the gutter is normally fixed onto, might need to be replaced potentially if they're in really bad nick, or repainted if they're in decent nick. If the roof felt is an issue, you might need to sort of take back a few layers of tiles and put something underneath the roof felt to sort of support it and ensure the water sort of flows off and into the gutter. Yeah, there's a couple of things you might need to do just to make sure that you do a good job. Basically, you leave a good job. Generally speaking, if you're fitting a gutter, normally if you just fit one just the same as the old gutter shape, then you're going to be fine. Or if you fit one with a larger capacity than the old one, then you're definitely going to be fine. But there are calculations you can do. They're described in Part H of the building regulations. You can sort of see it here. There's actually also a slightly different calculation described in BSE in 12056 as well. And both of these will essentially tell you sort of what sort of capacity of gutter you're going to need. But luckily, we don't need to worry too much about this, because it's not, the calculation's not going to come up with the test. And like I say, in real life, generally speaking, you just fit the same gutter shape or one with a larger capacity if you ever do work on an existing property, you know. And if you are, so make sure if you do work on a new build, for example, you need to know certain things. You need to know the rainfall intensity, the area and the slope of the roof, and where the outlets are, because we've already talked about if the outlets are in the middle, they can actually service a bigger area than if you have a single outlet at the end. There's some info here on the right from the manufacturer's information. I can't remember which company it was, but the companies are going to differ slightly, but they're largely going to be pretty similar. Actually, it's worth looking at, because it actually shows you, if you actually put it at a run, it shows it as a fall of 1 in 350, which is actually the maximum fall that it recommends in BSE in 12056. Though in the test, we're going to sort of say a recommended fall is 1 in 600. Okay, because that's the one that guilds like to ask about. I really don't know where they've got that number from, but that's what they always ask. 1 in 600 is the fall for gutter, according to City and Guilds. Okay, and it sort of shows you the different capacities. So, if, for example, you can see for half round, if it's level, it can service 44 metres with what the outlet at the end, 44 metres squared of the roof. But if it's got a slight fall, it can offer 56 metres. It can take water from 56 metres squared from the roof. But if it's fixed level, sorry, if it's fixed at a fall with the outlet at the centre, it can actually sort of take water from 125 metres squared of roof. You know, so it's a huge difference. Just having this fall, having the outlet at the centre, can make a significant difference to the effective roof area that the gutter can serve, essentially, you know. And you can also see, if we look here, the different types of gutters. So we've got our half round, a square, deep flow, and OG. We can actually see OG for this manufacturer can service the largest area, with sort of half round being significantly smaller in terms of its capacity than all of the other types. Okay. So if you're looking for where the rainwater pipes are going to drop to in a new dwelling, you'd ask the main contractor for the building plans, which would show the underground drainage positions. It'd also let you know which type of drainage system it's likely to be, if it's going to be a separate system, combined system, etc. Okay, so I'm going to briefly sort of do an introduction to the roof here. This up here kind of shows that these things coming down at an angle, these are going to be the rafters, and then at the front of the rafters, the front bit where you're going to fix the gutter onto will be described normally as the fascia. The bit underneath that would be described as the soffit. Just a bit extra info there for you. Okay. Generally speaking, most buildings are going to have a fascia board. Not all of them do. If they don't have a fascia board, then you need to look at other methods of fixing your gutter brackets. Okay, and we're going to look at different types of gutter brackets now. Okay, fascia bracket would be fixed directly onto the fascia board, like the example you can see here. But you can also get rafter brackets. You can get top fixed rafter brackets, which would fix onto the top of the rafter, side fixed rafter brackets, which would fix onto the side of the rafter, and drive-in brackets, which would be driven into the brickwork, hammered into the brickwork. And yeah, I mean, we all want to make sure that we sort of, when we fit our brackets, we fit them at a nice gentle kind of fall of 1 in 600, and we make sure that we have the appropriate spacing between brackets, which is a maximum of 1 metre for normal conditions, or if it's likely to be exposed to high winds or snow, a maximum of 750 mil. Okay, we also need to make sure we appropriately support our fittings, and we're going to look at that now. Okay, so our fittings, any unsupported fittings, for example angles, possibly you might have an unsupported running outlet or unsupported union. They should have clips within 150 mil of each side of them, and that's just to support the fitting, essentially to stop it sagging or any sort of damage occurring. Worth noting, when we do fix our brackets into position, we'd normally use sort of brass screws, stainless steel screws, possibly zinc coated screws, to fix them in position, because they're going to be installed outside and need some sort of protection foam, because it's going to be damp out there from corrosion, due to sort of rain and the air, atmospheric corrosion. Okay, so calculating the fall. Okay, we can actually quite easily calculate the fall. We essentially just divide the total length by 600. So say, for example, we had a 6 metre run of gutter, which would be 6,000 millimetres. Divide the 6,000 millimetres by 600, and that would give us, in this case, 10. So the total fall over 6 metres would be 10 mil. Same goes, say for example we had sort of 12 metres, it would be 12,000. 12,000 divided by 600 would equal 20. So the fall over 12 metres would be 20 mil. Okay, and so on and so forth, right? So yeah, so to make sure you actually sort of get the correct fall, is to work out what the fall is going to be over that distance, fix your top bracket in position, and then sort of go along to the other end of the run where the lowest point is going to be, measure that down from the edge of the roof, and then fix a string line between them. and then as you install the gutter fittings, you just offer up the fittings, the fascia brackets normally, up to the line, and then fix them in position, and you know that they're going to be at the right height. Worth noting, once all the clips are in place, you drop the gutter into position and fix your fittings in place. Make sure that you leave an appropriate expansion gap in the fittings. All plastic fittings have got a mark inside them, which is normally 10mm short of the centre, which is there for thermal expansion. Make sure that you leave that gap for thermal expansion, otherwise the system might start to bow. Essentially, if it's not got space for expansion, when it does heat up and starts to expand, then it will distort the gutter. You can work out exactly how much the gutter is going to expand by times in the coefficient of linear expansion, by the temperature rise that it's going to experience, and by the length as well. So whatever the temperature is going to go up in degrees, you'd multiply that by the length and by the coefficient of linear expansion. And very briefly, one last thing before we finish up, we're going to look at how we test gutters, and actually it's as simple as just running water through it using a hose pipe. Simples. Okay, and now it is time for your task.